So this is our agenda, and let's move to the real meaning of the definition file in PowerDesigner and what is it responsible for. As you can see, the basic schema of areas that are covered by PowerDesigner. You see the data modeling part, which is on the left-hand side. On the 3 levels: conceptual, logical, and physical data modeling. And the definition file is responsible for communication, mainly for communication between the physical data models and databases. So it takes care of reverse engineering from database to the model, forward engineering like DDL script generations and directly to database generations. And of course, it can handle some part of the extensibility inside the PowerDesigner tool. The definition files are one of many resource files which are available in PowerDesigner. Each supported version of a database like Oracle 11, Oracle 12, Oracle 18, Oracle 19, SAP databases, IBM DB2 databases, Microsoft SQL Server, and so on. You see almost all of them on the right-hand side of the screenshot. They are supported, and each of these supported version of database is represented by one definition file stored in the PowerDesigner installation folder. These are XML structured files. They are open to modifications, so feel free to modify it as you need, but there are, let's say, several bugs, or maybe I should say several don'ts. And one of them is that you should never modify the original XDB file. What does that mean? It means that there is a huge problem coming if you modify the XDB file and then the new upgrade of PowerDesigner comes, or you reinstall it. It is very probable that your definition file will receive a patch, and the patch will rewrite your modified file. So never modify the original XDB file. And trust me, I have several experiences of how I lost some of my work because I didn't realize that I'm modifying the original file. So please pay attention to this. Make a copy in a proper way. What does that mean? Is copying file to a copy on the file system, isn't it enough? No, it's definitely not enough, and you should make the copy in a proper way. That means that you should save the definition file in its own internal PowerDesigner editor and save it as a new file. The reason is that the definition file contains internal IDs which are widely used across the whole PowerDesigner environment, and if you don't use this function and just copy the file on the file system, you will get another file with the same IDs, and it will cause trouble later. It doesn't have to show up immediately, but for example, when you do upgrades of PowerDesigner to a newer version, you can run into serious trouble when you have duplicated IDs in your resource files. Don't modify XML content directly. However, it might sound tempting to do some direct modifications in the XML file. As you can see on the screenshot, it seems quite readable if you look into it for a while, but don't ever do that. I have one example for all. I experienced that someone manually pasted multi-line text into single-line properties. So, however, it might sound like a piece of cake to modify this definition file directly. You can paste a multi-line into a single-line property, and then trust me, you will start seeing things in PowerDesigner. You might have some missing information there, or you might see some overlapping on the diagrams, and it can have many consequences that you don't want to deal with. So don't modify the XML resources directly. Use always the internal editor. And for the third, don't let each user to maintain the definition files individually. The definition files are meant to be, let's say, maintained or managed centrally, and you should use only, let's say, approved version of the definition file, and have the same settings on each workstation, on each computer where the PowerDesigner is installed or used. Trust me, this can save you a lot of trouble in the future. So let's move on. Let's start with working with additional metadata from database. Of course, you are, at least some of you are experienced PowerDesigner users, and you know that PowerDesigner can quite easily do some, let's say, standard reverse engineering from database, reverse engineering the standard objects like tables, views, procedures, users, schemas, table spaces, and so on and so on. What I want to show you now is that you can, let's say, work with some additional metadata which are specific for your specific environment, for your company only. So let me please show you a video which I have to pre-record because it was created in the customer's environment and it's behind VPN, so I'm not allowed to be on Teams and VPN as well. So now you should see PowerDesigner. Let me put it full screen. If you don't see it full screen, please let me know. Right now I'm starting the video and I hope I will comment it for you as well. So right now I'm starting standard reverse engineering, just defining the name of the model and using the source database. Defining the data source I'm using for the reverse engineering and for connection to the database, of course the login and password. And I'll choose just one single table. And let me show you one single table just reverse engineered in a brand new model. And as you can see, I have some extended attributes here, and one of them is project. And the value is there. This is definitely not a standard feature of PowerDesigner. If I switch back, okay, this is what I was looking for. One of our customers is using some additional metadata in the database to distinguish between the tables, because they are working on the project basis and each table is being created for a certain project. So this is very important metadata for them, and they need to have it defined for each table. So when you are, this is a screenshot from the Microsoft SQL Server Management Studio, where you can define your own extended properties, and one of them was created as a project and it has its own value. In our example, the value is MIS, and this is the information I want to work with when I'm doing reverse engineering of the model inside PowerDesigner. So let me switch back to PowerDesigner, and this is how it ended up after reverse engineering. So how was I able to get this information into the PowerDesigner? When I open up the definition file, I see one of the sections there is responsible for reverse engineering of the database. So when you go to the script, objects and table, you see the items that are responsible for doing something with tables, and the parts, the items beginning with the prefix SQL, are responsible for reverse engineering. So what you see right now in the screenshot is a SQL query, which is asking, which is querying the let's say system metadata of a Microsoft SQL Server, and the result of this particular query is the list of objects that you are allowed to reverse engineer. So when this query is performed, you get in the PowerDesigner user interface, you get the list of tables that should be reverse engineered. So this is the standard procedure how reverse engineering works. If we want to enrich it a little bit, we have to modify the definition file, and right now I'm going to show you how I got this project information into the model during the standard reverse engineering. So right now I'm opening the definition file, going to script section and objects. Of course, the metadata belong to tables, so I go to table, and these are the reverse engineering related items. This is SQL attribute query, which is responsible for retrieving additional information about tables, not only their names and their owners, like the schema which it belongs to, but also other options and other additional metadata. As you can see here, this is pretty standard query. I made only a couple of changes here. One is I joined another system table, like called extended properties, and I'm interested in the extended properties called project. I put it as one more column into the result set of the query, and I put it as a separate variable. As you can see, this query has 4 columns. It returns 4 columns, and here are four variables which are being taken over by PowerDesigner and being transformed into the model. So this is the very algorithm that PowerDesigner uses to create the model through reverse engineering. So I modify these 3 rows, only these 3 rows, and the result is that I'm able to get the project information from the database into the model. Okay, so let's move on. I have a second video here that gives us some more insight into this. Let's say in order to be able to maintain this additional property inside PowerDesigner, we have to define it somewhere, and that's what I'm going again into the definition file, and that's what section profile is about. Here I found the table meta class, and here we see that I only define simple string typed extended attribute and named it project. Maybe for a more attractive presentation to the user, I can put it on a separate form and present it this way on a separate form, and here we have this value. Okay, so we are now handling this project inside PowerDesigner, but we are one important thing missing: how we can get it back to the database. Okay, let's look at the preview here, and among, let's say, standard DTL definition, you see that PowerDesigner is capable of producing. We have here something extra. So this is the create table statement for our table. This is the standard command. It's table command, which is being generated to Microsoft SQL Server as a property called MS description. And right below it, we have our project with the proper value. And this is the result. And the result of which modification, that's what I'm right now going to show you. So we know how to reverse engineer it, and we now want to alter the DDL generation template, and we go the same way as for the reverse engineering. So it's the section script, objects, table of course, and because the create item is, let's say, quite simple. We are using, as you can see, not many entries here. By the way, the person sign shows us the variable in a language called GTL, Generation Template Language, which is quite essential for modifying these generation templates. But what we have used for generating DDL of our project extended property is that we put it at the level of table comment. So here you can find the item called table comment, which is being automatically added after the create table statement. So what you see here is the template for the comment being generated, and what we did is just we added a couple new rows that are generating the project extended attribute. I can prove it to you right now. If I put some characters here and make a refresh here, you see that it automatically and immediately propagates to the generated DDL. I will delete it and remove it because of course it doesn't make sense, but just for you to see how you can verify your immediate changes into the definition file, how you can validate them and see what is the real output of your modifications. Okay, so to summarize this first scenario is that we modified, or we showed how to modify reverse engineering algorithms. We showed how to maintain extended properties of Microsoft SQL Server in PowerDesigner, and we modified the DDL generation as well. My point here is that all I need to do was to modify 3 rows for reverse engineering, define one extended attribute in the profile section, and edit 7 new rows in the script objects table section. The point here is that it is very, very simple if you know where to touch, where to put your modifications. It doesn't take a lot. You just need to know where to modify it. So PowerDesigner, what I want to say by this is that PowerDesigner is quite open to modifications by any user. It's quite simple if you know where to look. And the only thing you need to take into account when you are dealing with modifying the DDL generation is the GTL generation template language, which is a quite simple macro language, but it, let's say, takes some while to get into it very, let's say, in such a way that you are able to use it as your native language. Okay, so let's move on. I have another example here. We are still working with some additional metadata, and this time it's not from database into PowerDesigner, but it's from PowerDesigner. So it's a metadata that are that I want to, let's say, be part of the generated create scripts and alter scripts, but they are actually not part of the database metadata. I just want to, let's say, kind of enrich the generated DDL script. Okay, so let's start with the example. What you see here on the screenshot is that I created a completely new tab in the properties of the model, of the physical data model, and among other things, it shows some deployment log, which allows me to understand who, when, why, and what did in the model. So I have some user IDs, I have some dates, I have some IDs from requirement system, and some comments that I want to be part of the generated alter scripts. And I am of course interested in the most recent record of this deployment log. Okay, so let me Let me show you how it works. What I have here is a simple model with just 4 tables, and the deployment log is here. IDs, dates, comments, and this is the latest record I want to be part of the generated create script. So among other statements like create tables and defining properties and defining comments and projects and so on, as you can see here, I have a first row as a part of the create script, and this is exactly this one. If I create new record here, you see that some parts like user ID and date are predefined automatically, because why should we bother the user with some things that could be quite easily automated? I just need to fill in the ID of the requirement and define the command. And this is the most recent date, so I want to be, as you can see, I want to have the most recent record to be part of the preview. It is there. So how did I achieve that? I have to go again into the script SQL section. So it sits next to the object section, and here are, let's say, quite a few interesting items that are taking part in the generation process. One of them is header, and this header contains a reference to a template or to extended attribute defined somewhere in PowerDesigner. The attribute is called deployment record preview, and the prefix .d means that it is defined in another resource file than our definition file. So you can have all these extensions defined in your definition file, or if the situation requests it, you can define it in your separate extension, and you can reference it like this very easily just with the .d prefix. So this deployment record preview is defined in the extension which is attached to the model, and it is at the model level. So I go to the model meta class. And here you see the deployment record is a simple computed extended attribute, which is just browsing the deployment log and taking the most recent record as the part of the generated file. That's all. That's the only thing you need to do when you want to just attach some additional data in your definition file. In your generated DDL script. One more thing. Not all the items you see here in the script section are by default visible. Trust me, this is quite important information, and I spent a lot of time exploring how can I do certain extensions, and then I revealed that some items have to be added through this add items command. So for example, when you need to modify the footer of the alter script, you have to edit first like this, and after that you can modify this field to be attached at the end of your alter script. This is again the GTL enabled field, so you can use the variables and the macros allowed for GTL language here, and use it, let's say, bend the process of DDL generation exactly to your needs. Okay, so that's for this another demo. Maybe let me check if there are some questions. Okay.
About 20 seconds ago, I asked people to put questions in the chat window.
Okay, okay. And do we have there something? My PowerPoint is overlapping the Teams window.
So far, we have Carol actually suggesting that he can give you some hints and tips about JDBC drivers. Okay, we don't have any questions as yet.
I have notes. Okay. So maybe we should proceed with our demo, and let's move on. Data types translation. I bet you, all of you, experienced at least one time the necessity of migration from one database to another, like migrating from Oracle to Microsoft SQL Server. That's what is my next demo going to be about. And one of the key questions is how to handle the data types, because you have to rely on PowerDesigner that he will handle the data types correctly. Of course, he most probably will handle the data types correctly, but you might have some, let's say, specific modifications or a specific type of data that you want to migrate from Oracle to Microsoft SQL Server in other than, let's say, standard way. You need to use another data type than it is used as default. So let me show you how it works. What we have here, two yellow rectangles representing the definition files. One is for Oracle definition file, second is for Microsoft SQL Server. So you can understand it as let's say two models, and the Oracle definition file, of course, defines the Oracle data types and so on. So how PowerDesigner handles this translation is that it translates Oracle data type into kind of an internal data type. This internal data type is being transferred without any change from one model to another, to the Microsoft SQL 2016 here in my example. And here the internal data type is being translated to the Microsoft SQL data type. So this translation is already built in the PowerDesigner standard definition files. We have to take into account two definition files, and I will show you how we can modify it. Okay, so let me switch to PowerDesigner, and this is what we have here. We have one simple table here with a couple of columns and their data types. And if I want to do the migration, I could just simply go to database and run the change current DBMS. I could definitely do that, but it would mean that I will lose something. I will lose the original file, the original specific object, because I will lose the Oracle specification of that model. So instead of this, I rather recommend going to Tools and Generate Physical Data Model. Let's call him SQL and run it. If we do this, we do not lose the original file, and we can, let me put it like this. By the way, did you know that you can display multiple models and multiple diagrams like next to each other? Okay, so this one is Oracle, and on the right hand side it's Microsoft SQL Server. It just took over the name from the Oracle model, so I will just change it here. Okay, now it's better. And let's say we have the column 3 and it says nvarchar 2, and it was translated as varchar. This is what I don't like, and I want to modify, I want to alter this behavior. So what I need to do in order to achieve that modification, I need to open the definition file. So first of all, I will open the Oracle definition file, put it, let's say, somewhere here, and then I will switch to the target file and open the definition file for the Microsoft SQL Server. Okay, now we have to go again to script and the data type section. I will do the same for the Oracle. Oh, sorry, data type. And this is what I need to see. Okay, so on the left hand side, this is the translation of Oracle data types to internal data types, and it contains our envarcar 2, I believe. Let me find it. Okay. Now I cannot find it right now, but I believe it is there. envarcar 2 here. That's it. And we see that it translates into this. This is the name, and this is the template of the internal data type. If I find the same data type here, when translating on the Microsoft SQL Server side, I see that this precisely the same template is being translated to varchar. So now I have to decide whether I want to influence rather the output of the Oracle data models, physical data models, or if I want to modify the input of the Microsoft SQL Server models. In our example, I will do the modification here. So I want to modify the output. So I want envarcar 2 to be translated as envarcar here at Microsoft SQL Server. So I will find envarcar. Yeah, it's the template. That's the template for the length of the data type. So this is our internal data type. So I just copied it into the clipboard and I will just paste it here. So let me close it. I just have to apply it in the Oracle definition file. Now let me close this target model we just generated, and let me generate it again. We are at the Oracle data model, as you can see in the right-hand bottom side of the screen. And now I'm generating the physical data model. Let's generate new model, MS SQL number 2. And now if I put it next to our original table on the left-hand side, now we see that the envarcar is there. So another very simple modification, but it can save you a lot of time, a lot of work, and a lot of your effort to trying to do the migration right. So knowing this, you can let's say handle the data type translation very in a very detailed way, and it should not surprise you in anything. Of course, there might be still some scenarios where you will have to do some scripting there, but most of the issues, most of the problems can be solved by this simple modification of the data type translation. So physical data type, this is the translation from source data type, source database into the internal, and AMCD data type, this is the translation from the internal data types into the target data types. Of course, there are more items, there are more bridges or translation dictionaries, however we want to call it, but this is beyond the scope of this session. Okay. So to summarize it, or to summarize this scenario, you can define or redefine data type translation. You can modify the list of the data types, and you can add your own data types. That's what I didn't show you. So if I just go back to the definition file. You can very easily define your own data type. However, it doesn't make sense, but if you, for example, are using very often the data type, let's say we took nvarchar, so let me use it once again. So let me find it. Oh, we are at the Microsoft SQL Server. Sorry, let me go back to the Oracle. Okay, nvarchar here. So let's assume that very frequent data type length is 20. So that's what I want to add here manually to save some time here. So let me do it like this. That's all you need to do. And this is how I put a new data type, which is in fact based on already existing data type. But if I create new column, I can choose, let me spread it a little bit. I can choose from the hour. Here you see nvarchar 220, already predefined length. And that's how you can save 1 or 2 seconds of each column being created if some kind of a data type is being used very often. And of course, it will be translated as all other data types of nvarchar according to the translation bridges. Okay. So I think this is the last example I have prepared for you today, and it's about transformations. What is a transformation? It's any scripted batch operation across the model. Fine, but what does that mean in real? You can do many operations which are, or which let's say require batch processing, and you can define them inside your definition file or inside your extension, and you can use it among your models. One of the things you can do, you can attach, let's say, missing technical columns to tables. You can put automated view creations on certain type of a table. You can set physical options like, table spaces, partitioning, and so on to objects like tables and views, and you can set it differently based on their different types. So that's one of many examples you can use transformations for. And there are 2 ways how you can use these transformations. One is displayed right now on the screenshot, so you can run it through the tools and apply transformations. And if there are some transformations available either in your definition file or your extension, you will most probably see them here in the dialog box on the screenshot. My example will show you the second option, how you can apply transformations, and I believe it is not so widely known, and I believe that all of you who are using both logical and physical data columns will appreciate this let's say knowledge. It's about pre-generation and post-generation transformation. What does that mean? It means that when you have logical data model and you have attached, or you already generated a physical data model of that logical data model, and now you made some modifications to your logical data model and you want to apply those changes to your physical data model. That's a scenario which is quite common, and it might occur that you need to, let's say, make some adjustment before you start the generation, because how the generation works, you run the generation from the logical data model. In the background, PowerDesigner automatically converts this logical data model into the temporary physical data model, and that's when you get this merge models window, and you are comparing one physical data model to another. The left-hand side physical data model was generated from your logical, and the right-hand side is your target physical data model you need to update. So this is the logic in the background. And the pre-generation and post-generation transformations allow you to run these transformations as a part of this update process. So pre-generation transformation means that you can modify by your defined script the objects in your logical data model, and I mean objects like entities, attributes, domains, relationships. After that modification, the temporary physical data model is being generated, and the post-generation transformation is being applied to it. So right now you are dealing with tables, indexes, keys, and so on. And after that, the merge models window is being displayed. So there were already two kinds of transformations done on the way before you get this, let's say, final merge model window. And let me show you an example of that. Yes, demo. That's it. What I have here is logical and physical data model. Okay, let me show you the logical data model. It contains one simple table, and as you can see, the data types of those attributes are, let's say, are not common data types of any database. You might know they are internal data types used by our customer, and of course, if you put your own data types there, they will be translated to the physical data model as they are. So you don't want to have a data type called code or numchar in the physical data model. You need to use the data types that are physically allowed to be there in the database. So how we are going to do that? I'm going through tools, generate physical data model. PowerDesigner already found out that my target physical data model is there and is open and is present in the object browser. So it offers me the option to update existing physical data model. And what I have to do is go to the Detail tab, enable transformations, allow, check the extension that is needed or that contains the conversions. And right now you see LDM PDM transformation, data types conversion. What does it mean? We have a short description here, so let me do this. It converts logical data types to appropriate physical data types based on internal rules. Okay, that's a pre-generation conversion. And we have one post-generation conversion, which converts logical codes to physical names. And it is for the column meta class. It means that at logical level, the customer wants to have different names and codes for the attributes, as you can see it here. But at the physical level, he wants to keep names and codes the same. So in order to prevent these long names to be generated to physical data models, we have to do some post-generation or pre-generation transformation. So let me run it finally. Enable transformations. Okay, data type conversion is turned on. Logical codes to names turned on again. Okay. And now what we see here. Okay. On the left-hand side, there is the temporary physical data model already generated after applying all the transformations. So if I open up the column from the temporarily generated physical data model, you see that the name of the column is the same. It doesn't contain the long name anymore. And you see the data type. It's not code or numchar. It says car3. Another column. Okay, let me take this one, for example, car4. Okay, so you see all the transformations were applied. And what I see now is the final model after all the transformations applied. So I can choose. I have some differences in the extended attributes too. I will not apply them, and I will apply the comment there. So that's it, and my changes were applied. And as you can see, no long names there, and proper data types are present. Okay. So we are going to the summary of our session. I want to emphasize a couple things that I want you to carry on from this session. And I want you to remember that definition files allow you to modify the reverse engineering algorithms. They allow you also to modify or enrich the DDL scripts creation. We showed 2 examples of that. They allow you to alter the data types translation when you need to migrate from one database to another. And they allow you to define transformations in models. So in fact, the only thing I want you to remember is the customizability of PowerDesigner to support your processes. It means PowerDesigner can be customized and extended in in many various ways, and this allows the tool to, let's say, accommodate to your processes, and it does not force you to change your processes to the tool. Of course, it brings a lot of, let's say, best practices and guides you through the whole development and documentation and analysis process, but it allows you to modify the tool so it supports your processes in, let's say, most efficient way possible. I think that's the final final thought of my session.